Engineering, St. Joseph College of Engineering, Chennai. I especially want to welcome our guest, Dr. Emmanuel Vincent, Research Professor, INJE University, South Korea. Our HODs, Dr. R. Bhaskaran sir and Dr. N. Venkatesh sir, my colleagues and participants from various institutions. To start with, fuel cell combines hydrogen and oxygen to produce electricity, heat, and water. Fuel cells are often compared to batteries. Both convert the energy produced by chemical reaction into useful electric power. Fuel cells are promising technology for use as a source of heat and electricity for building and as an electrical power source for electric motor propelling vehicles. Fuel cells operate based on pure hydrogen, but fuels like natural gas, methanol, or even gasoline can be reformed to produce hydrogen required for fuel cells. Some fuel cells even can be fueled directly with methanol without a reformer. More than 90% of hydrogen is used as a building block for fertilizers or it's consumed within oil, refining, and wider petrochemical industries. Our guest will explain about the importance and applications of hydrogen energy and fuel cells. Now, I will hand over this session to our guest, Dr. Emmanuel Vincent.
Thank you for the brief introduction of fuel cell and hydrogen energy. And thank you for arranging this webinar. Today I am going to explain about hydrogen energy and fuel cell. As you know, before going to presentation topic, I would like to introduce about myself. As you know, I am Dr. Emmanuel Vincent, currently working as a research professor in INJE University, South Africa. Also, I am working as a brain pool scientist fellow in that university. Before coming to INJE University, I worked as a project researcher in the University of Tokyo, Japan. And before that, Northwest University, South Africa, and Ben Gurion University in Israel. I completed my PhD in chemical engineering from Indian Institute of Technology, Delhi. So today, I am going to explain about the interesting topic of hydrogen energy and fuel cell. Before coming to the point, I would like to touch the energy and renewable energy and why we need hydrogen energy and fuel cell. So today, these are the topics I am going to explain today. First, the energy. Energy is a very common terminology nowadays because everybody know about energy. Energy is defined as ability to perform some work. So that is called energy. It's very common terminology. Every people knows that, even kids knows about energy. The unit of energy is kilowatt. So energy, everybody need energy. If we want to walk, we need energy. If you want to ride a bicycle, we need energy. If you want to ride a car, we need energy. But it's a different form of energy. And if you want to watch a TV, we need energy. And if you want to work on computer, we need energy. Energy is not only the physical energy. Energy is available in various forms. So we are using that energy according to that purpose. By this time, everybody knows about energy, about some common facts of energy. What is energy, where it is coming from. So generally energy, people think it's coming from the combustion of fossil fuel like a petroleum and natural gas or coal, or from the nuclear energy. So nuclear energy is converted later back into the electrical energy as electricity. And next one is the people, everybody know about the electricity. But electricity is not a primary energy source. It's a carrier. It helps to store the energy and helps to transport the energy according to our use. And in the history, energy is very, very important for the humankind. There are many wars have been fought to conquer the energy resources. So if the country has the good energy resources, the country would be the rich nation like Saudi Arabia, United Arab Emirates, and Qatar. It's like the country, they have only the energy resources other than nothing, but they are now the rich countries. Likewise, if the country has a good power but it does not have the energy resources, so it's developed is hold back its development, means it leads to the poverty. So energy is available in various forms. According to first law of thermodynamics, energy cannot be created or destroyed, but one kind of energy can be transferred into another kind of energy. So here some forms of examples of energy. So one is heat energy. So everybody know about heat. Heat is very common in everywhere, it's available. So heat energy is released based on the due to the result of atom movement. And next one is electrical energy. So electrical energy is created by the flow of electron from one place to another place. So when the flow of electron create the electrical energy. Likewise, potential energy. Potential energy is the internal energy for the any material. And chemical energy, and energy is stored in the form of chemicals, and it can be released by the chemical reactions. So that is called chemical energy. And finally, nuclear energy. And nuclear energy, the nuclear, when we break the atoms, so it releases its energy, and later it converts to thermal energy or electrical energy. So these are the forms of energy available, and these are some of the examples of the different forms of energy. It's your chemical energy and thermal energy we use for heat, and potential energy and nuclear energy and electrical energy as a battery. So now where this energy is available, that is source of energy. There are two kind of sources are available in energy. One is non-renewable energy and another one is renewable energy. The non-renewable energy is once we use the energy, then we cannot recover. For example, if we use petrol to ride a car, after driving some distance, so we cannot get back the energy back. So that is called non-renewable energy. Likewise, we cook the food in the house. So when we use the natural gas to cook food, so after we cooking the food, we cannot get back the energy. So the energy is used to perform some work, and we cannot get back that energy. So that is called non-renewable energy. So like a coal, oil, gas, and nuclear, and these are the major examples of the non-renewable energy. So, but in still now we are depending on the same this non-renewable energy. Our energy consumption is increasing day by day, and this is the chart for the last 50 years what happens in the consumption of the energy. So from this chart we can understand the energy is consumption is increasing up to its last 50 years. When it is in last 1919, the energy consumption is low, but each year it is increasing. Now we are in 2020 and it is projected to 2040, so it will increase. So but the sad is we are still depending on the whole non-renewable energy, but eventually the demand will increase in future year. So these are some of the projected approximation when the demand will be huge in natural gas in 40 years, and coal we have some research, so it will go up to 180 years, and oil because we use very regularly, so it has only 30 years only we have enough oil. And moreover, around 80% of the world energy demand is still depend on the fossil fuel like a petroleum and natural gas. Okay, the demand is one side, that is one problem. But another side, when we use the fossil fuel, when it is burned to produce energy, it emits the carbon dioxide as a byproduct. So that carbon dioxide is not good for our earth, because the carbon dioxide emits and it increases heat by the greenhouse effect. So it's not good, it adverse the environment. Also, the fossil fuel, it's not forever. It has some amount. So when we use the fossil fuel, the depletion, it is keep reducing the source of the fossil fuel. So one day, ultimately, it will end and we will not have energy anymore. And the transportation cost is also very high to transfer the fossil fuel to one place to another place. But this is least challenges of the fossil fuel. So we must produce or we must rely on some another energy. Thanks for science and technology. But so this is the current situation when we use the our fossil fuel. So we cannot go for the long distance. So we must develop some renewable energy. So these are the renewable energy is available in the science and technology. So wind energy, solar energy, biomass, tidal energy, and hydrogen energy. So we are going to see briefly what about this renewable energy. The first one is wind energy. Wind energy is very common. We can see very commonly in India and other countries. If you go to southern part of Tamil Nadu, also in Nagarkoil, that side, we can see many windmill. So windmill is generally the electricity is produced from the wind. So when we have the wind, so the turbine rotates. So based on the rotation of the kinetic energy, so we have the electrical energy. This is very clean form of the energy, and nowadays the country is implementing more and more. But the one of the major problem is the maintenance cost is very high. Also the implementation cost also very high. But the another reason is it's not good for the animals. When the birds fly, there are many chances to die when it comes near the fence. So this is the one, but we cannot completely rely on this wind energy. So the next is solar energy. Solar energy is a common energy nowadays because everywhere we can see the solar panels. So solar energy is the energy directly comes from the sun radiation. So the energy, sun radiation is converted back into the energy. By this is also one of the clean energy method. It does not require any carbon dioxide emission. So when we use this energy, but the major challenges is it needs lot of space to produce the small amount of energy. So we need lot of space. The another one is storing of the energy. So once we harvest the energy, we must store the energy for the later use. But the storing in this battery is not good because we cannot store the energy what we harvested completely, and it's also again it's coming transportation and another major problems. So we cannot completely rely on the solar energy. This can work but some extent and some application, but not for all the application. So with these premises and background, I would like to introduce about the hydrogen energy. Hydrogen energy. So hydrogen, we always hear about hydrogen. Hydrogen, because it's not a strange chemical. This is one of the abundant chemicals in the world. It's available in the huge amount. But it is always in the another form. The hydrogen is always associated with carbon as a hydrocarbon, or it is associated with the oxygen as a water. So the hydrogen we have, they are not all available, but it is in different form. Also, this hydrogen is not a fuel; it's like electricity. So electricity means like its way of storing and transporting energy from one place to another place, similar as battery. And this hydrogen is not a new concept, it's one of the old concept. It has been, people are researching for more than few hundreds years before about the hydrogen energy. And it is the hydrogen energy is used in, there are many spacecrafts also. So this hydrogen has to be produced from its sources. So later we will see how it can be produced. Okay, now why we need to use hydrogen when we compare to another renewable sources or another non-renewable sources? Because the power density, the energy produced from the hydrogen is very high. When we compare with the fossil fuel, it's almost 3 times more than the fossil fuel. In the hydrogen, it's around 120 megajoule per kilogram. In fossil fuel, it's around only 40 to 50 megajoule per kilogram. So when we use hydrogen, there is no emission of carbon dioxide. So there is no adverse effect for our environment. So we can save our environment from the greenhouse effect and the global warming. And also, when we produce a lot of hydrogen, we no need to depend on the hydrogen import country from the Middle East countries. So we can own our hydrogen to our domestic and industrial purposes. Also, when we use hydrogen, we can save our fossil fuel reserved for the emergency purposes. So as you understand, we have a lot of hydrogen, but we must produce the hydrogen from its sources. The two kind of sources, one is hydrocarbon. Hydrocarbon is like a petroleum product, like again oil, coal, natural gas. So these are the methods to produce hydrogen: partial oxidation, gasification processes, and steam reforming processes. But when we take hydrogen from this hydrocarbon, again we have a problem. We may use hydrogen here, but when we produce hydrogen, so always the carbon dioxide emission and the depletion of the fossil fuel. So taking hydrogen from the fossil fuel is not a reliable method. So we have to look some other methods. There are some other few methods are available from the biomass, and some chemical method, but this is still under pilot stage, and the efficiency is not very high. The important another method is hydrogen can be produced from the method called electricity. So because the source of hydrogen is hydrocarbon and another one is water. So we have huge amount of water. So the water can be splitted into hydrogen and oxygen by using electricity. So we get at the later stage the electricity, so we need to give electricity, but there is a little strange because we have to give electricity to produce electricity. So because at the end of the day we will get nothing, so we have to get this electricity somewhere free to produce hydrogen. So one of the technology, electrolysis, but the renewable energy, we can see it is the energy, the electrical energy coming from the renewable energy. So renewable energy electricity is free, so we can produce hydrogen, and later we can use it for our specific purposes. So hydrogen from water is one of the long-term solution for production of hydrogen and renewable energy sources. So this is one of the method to produce hydrogen from water. It is called proton exchange membrane electrolysis. In this electrolysis, water is split into hydrogen and oxygen. So we can see this is the overall reaction. So we have water, it is split into hydrogen and oxygen by electricity. And anode, the hydrogen is oxidized and 2 H plus ions produced and 2 electrons produced. This H plus ions cross through the membrane and electrons is crossed through the external circuit. I will explain in the picture later. And likewise the cathode, the proton is reduced as a hydrogen to gaining 2 electron as a, then it's released as a hydrogen. So when we come back to the picture, so this is called a PEM electrolyzer. To electrolyze the water is called electrolyzer. So this electrolyzer has anode, is positive charge electrode, and the cathode, it is negative charge electrode, and the membrane, it's a polymer. It's a polymer. Many people know about membrane. So it's a polymer. So it has some specific property. It will allow only some specific charges. Maybe it's a positive charge or maybe in negative charge. So this is called ion exchange membrane. So this anode in cathode is separated by this ion exchange membrane. So we have water here. The water is fed to the anode. So where we supply the electricity, so due to this electricity, it's splitted, it's oxidized, it losing 2 electrons, and it's separating into proton and oxygen. So the oxygen is going and saving here, and this proton is exchanged from this anode to cathode, and the electron, it travel through the external circuit to reach the cathode. There it is reduced, so this protons gets these 2 electrons and become hydrogen. So this is the mechanism of this proton exchange membrane electrolysis. But this electricity we have to get from the renewable resources. Then this method is very useful, and this is possible to produce hydrogen energy. So still people are working on this proton exchange membrane electrolysis. Now there are anion exchange membrane electrolysis, that is reverse of this proton exchange membrane electrolysis for the hydrogen production. So now we produce hydrogen. Okay, so now how the hydrogen, from the hydrogen we can benefit? So we have need another device that is called fuel cell. So hydrogen is one section and fuel cell is another section. So we have to combine this both two. So what is fuel cell? Fuel cell is just like a battery. As he told in the introduction, it's just like a battery. And this, in the battery, we can refill the fuel. The fuel is hydrogen and oxygen. Air means we have oxygen in that. So we can refill this hydrogen and oxygen. So as long as we refill the hydrogen and oxygen, so we get the electricity from this fuel cell. So this is the common terminology of the battery and fuel cell, the difference in the battery and the fuel cell. So from this we can get easily produce 500 to 1000 amps of electricity very easily. So now let us see how the fuel cell works, because electrolyzer we have seen. Now fuel cell what is, but how it is work? It's just opposite of electrolyzer. So this is the fuel cell reaction again. So we have a hydrogen and hydrogen in the anode and oxygen in the cathode, and the water is produced here and the electricity also produced. So our main aim is to combine this hydrogen and oxygen to produce electricity. So this electricity will be used later for the useful application. So the hydrogen, it is oxidized in the anode and released 2 electrons. So the electron flow from the anode to the cathode. There it is reduced and the water is formed. So the byproduct of this hydrogen fuel cell is water, and the raw material is hydrogen and oxygen, and the main product is electricity. So we get electricity by combining the hydrogen and oxygen. So this is how the fuel cell works. So why is now, when we can use this fuel cell in the fuel cell vehicles, which has to be specifically designed in the future purposes. So why we need to go for the fuel cell? Because it can replace the internal combustion engine, which is run on the diesel or petrol or any other fossil fuel. Because this fuel cell, the efficiency is higher when compared to the internal combustion engines. The fuel cell efficiency is around 50 to 60%, whereas the internal combustion engine efficiency is around 15 to 20%. And when we use the fuel cell, we have some electrodes and membranes. There is no moving parts, so there is no noise. and there is no noise means less pollution, and little maintenance because there is no moving component, so the little maintenance, so we do not need much maintenance for the fuel cell vehicle. And there are no, because there is no carbon dioxide emission, so no environmental pollution. And because the byproducts, one is water and the heat, and this heat also we can use for some useful purposes later. And this is the one of the proposed model to use the fuel cell from the water as the fuel, because we get the hydrogen from the water. So this is the proposed model, but still it is underdeveloped. It is not commercially available. So we have water in the water tank. Instead of petrol tank, we have water. So from the water, we have some water splitting unit like electrolysis. And we split the water into hydrogen and oxygen. And that hydrogen is getting clean. And this is the input for the fuel cell. As I explained, the input for the raw material for the fuel cell is hydrogen and oxygen. So we have water and split the water into hydrogen and oxygen and produce hydrogen, and that hydrogen is used as a fuel for the fuel stack, and the oxygen we can get from the air. So here we can produce electricity and water. So based on this produce the electricity, this car can run, and the water can be sent to the recirculation. So now let's see a small video clip how the fuel cell vehicle is working. So this is the fuel cell vehicle technology. This is the model of the fuel cell. Hydrogen, oxygen reacts with electricity and water. And it has some provision of the hydrogen tanks and fuel cell and some battery and some electrical motor and some conversion unit. So when it runs, then the hydrogen comes from the hydrogen core and oxygen comes from the air, and electricity is produced in this fuel cell unit, and the car is running by this produced electricity. So how to fill the hydrogen in the hydrogen tank? So it's very easy, because within 3 minutes around 70 megapascal hydrogen can be pressure filled in the hydrogen tank. And when it is in the low loading, means the car is moving very slow, the energy can taken from the battery. But when we have the car moves very fast, little fast with the low driving, so we constantly get the electricity from the fuel cell. So from the hydrogen is coming and oxygen coming from the air and produced, and the electricity is produced, and based on that electricity this fuel cell vehicle is running. And when we need excess electricity, because we can take electricity to run the car from the fuel cell unit and the battery. Also we can, when the car is coming slow, so we can get the energy back, and that energy saved in the battery for the later purposes. So we can use this energy later. So this is how the fuel cell car works. And now let us see what happened inside the fuel cell. It's a single unit of fuel cell. As I explained, hydrogen and oxygen is the fuel. The hydrogen and oxygen, it's get oxidized and it is reduced. And here, due to the oxidation, the electron flows here. Here we can see the electron flows. So the flow of electron is electricity. So from that electron flow, that electricity, the car is running. And the byproduct is water. Just here oxygen and hydrogen is joined and water. So just the byproduct is water and the main product is electricity. And this is the way the fuel cell vehicle is work. So the renewable energy and the hydrogen and the fuel cell, so it is possible to make the fuel cell vehicle. So now we'll go back to our presentation. So this is hydrogen fuel cell and renewable technologies are already proven, and people are sincerely working to commercialize this fuel cell vehicle. And I hope within 10 or 20 years, it will be very common in our roads. But at present, we are continuously research on a new technology called URFC. URFC is unitized regenerative fuel cell, because as I explained, electrolyzer and fuel cell separate unit. Now we are merging this unit as a single unit. So based on this single unit, we produce hydrogen when it is in electrolysis mode, and we produce electricity when it is in fuel cell mode. So we get this electricity, and we have water, just water and electricity from renewable energy sources. So from that we produce hydrogen, and later that hydrogen is used as a fuel for the fuel cell, and then it can be used for the end purposes. So same single unit is called unitized regenerative fuel cell. So if this technology developed and it is commercially available, then we can use this technology for the unmanned aerial vehicle. So if we develop this technology, if we fix this URFC cell in the unmanned aerial vehicle like a drones, then up to 6 months to 1 year, we do not need to spend any energy for that. So it can automatically used if this technology developed and approved and commercially available. So we are constantly working on to develop this technology. And apart from this URFC, another technology is called solid oxide fuel cell. Solid oxide fuel cell, they use the electrolyte is the solid oxide. So this is called high temperature fuel cell. So in this fuel cell, it works above 900 degrees Celsius. We cannot imagine how heat is. So developing materials to work on this high level temperature is highly challenging. So that is the another work we are trying to do next work. So if it is developed, also we can waive all our old fossil fuels like natural gas, jet fuels, diesel, and biofuels. Okay, so this renewable energy, this fuel cell and hydrogen, it's a interdisciplinary research area, because nowadays we all depend on each other department. It's chemical engineering, mechanical engineering, physics, chemistry, civil engineering. We all need to develop this technology. For example, physics department of physics, they work on the photovoltaic, means they get from the electricity from the sun, and the chemistry, they work on the materials for the what kind of membrane and what kind of polymer they can choose and how to modify the polymer and electrode. And civil engineering, they are working on the wind energy and transportation of the energy from one area to another area. And chemical engineering, they mainly work on the fuel cell, because we related with chemical reaction engineering, because this fuel cell is working based on our chemical reaction engineering. So many chemical engineer, they work on the fuel cells and also getting energy from the biomasses. And electrical engineering, they are very, very important to make the fuel cell cars, hybrid vehicles. And mechanical engineering, they also need for the wind energy and the fuel cell car. So it's like a cooperation we need to make success of this fuel cell, hydrogen and energy. So with this, now I conclude this presentation. So hydrogen and fuel cell technologies are promising and alternative technology to our current automobile fuels. But still, there are many challenges that needs to be addressed. So one of the major challenges is storage, because we can produce hydrogen. So it has to stored in a big hydrogen storage tank, and transportation is a bit challenging from one place to another place. So that is why we are now concentrating on the hydrogen storage like a URFC. And another one is the cost to produce hydrogen. If still to produce 1 mole of hydrogen is very high to get the energy. So if we produce 1 mole hydrogen and we get some energy, but the energy is very less we give more energy to produce to get the less energy. So still these are the challenges. It needs to be addressed in future. I hope it will be addressed soon. So we and all over the world constantly working to make this technology commercially available. Okay, so thank you for listening this presentation. Thank you so much.
Sir, there are few questions from the participants. Can you please answer them?
Yes, of course.
Sir, the first question is from the participant named Dharani Dharan, and his question is that is there any way to store the hydrogen fuel in rocket, or whether they'll be just filled before the launch?
Yeah, actually, there are many different ways are now that previously they just depend on the storing in the cylinder. But now they adopt one new technology called LOHC. So liquid organic carriers. Liquid organic carriers means the hydrogen it's stored in the form of some chemical bonds. Okay, so they keep just some chemicals, that is LOHC. So that chemicals, so the when the bond is broken, so the hydrogen can be produced. So now previously they keep the hydrogen at the time of launching, but now they keep it in the form of LOHC, and that can be later used to for the energy.
Sir, and the second question is from the participant named Sujita, and her question is, can hydrogen serve as a safe green fuel for transport?
Yes, of course. Hydrogen is dangerous, but when it is unattended or when it is not safely handled. But for the when it is come to as a fuel, and of course it's a very green when we use the fuel cell, but extra safety must be take care to completely run safe and green. But still we are working for that, and so far still now it is very safe, but still we are trying to increase the safety of the fuel cell and hydrogen for the green energy.
Sir, and the next question is from the participant named Murugapan, and his question is, what are the current challenges to hydrogen fuel cell adoption?
Well, the major challenge is as explained storage. One is storage is still major challenge, because if you want to the implement of hydrogen cars, so we need to make like a fuel bank. Like now we have a petrol bulk everywhere, right? So like that we must have the hydrogen fuel bulk. So that is the one of the biggest challenge, because it must be stored in that, and making this hydrogen bulks all around the world, that is the one of the challenging. And another challenging still the cost wise is still the production cost of hydrogen is still little expensive than the fossil fuel. So that also need to be adjusted. Means I already explained, to produce 1 mole of hydrogen, we spent almost around 600 kilojoule, but we get the energy is almost 250 kilojoules from 1 mole of hydrogen. So still around almost 400 kilojoules we spent extra to produce get the energy. So that is also need to be addressed. That is why we are constantly increasing the efficiency of the hydrogen and the fuel cell.
Sir, and the next question is, can the hydrogen withstand the temperature produced during traveling?
Yeah, that is because already we have the hydrogen cars from the Toyota, Mirai, and the Honda from the Japan, and now there are few hydrogen fuel cell cars, so that can withstand our temperature. It's because the hydrogen is stored in the cold temperature in the tank, so as a liquid. So it's stored in the cold temperature, so it can withstand, no problem.
Sir, and the next question is from the participant Namda Kishore, and his question is that what is the problem in storing liquid hydrogen inside a car?
Yeah, like there is one of the still that is the major challenges, because when we store the hydrogen in the form of liquid, so when the temperature is when it's in our area it's not a problem, but it is in the mountain area, and when it is in some other breakage of the car or something, then it has the big chance to blast, but it's not very difficult to store. It's not the major problem.
The next question comes from the participant named Niranjan, and his question is that what are the threats in producing hydrogen fuel cells? Is there a way to reduce the cost of production since it's expensive nowadays?
Actually, somehow still the threat is two sides. One is from the political side, and another side is from our side. Okay, still the still many countries, they do not want to produce hydrogen. If the hydrogen, the people find the way to produce the hydrogen, and people find a way to use the hydrogen, their country economy may go down. Some other countries economy may go down. So that is on political trend. And otherwise, still the most of the hydrogen is produced from the hydrocarbon. So we have a lot of hydrogen. So most of the hydrogen is not produced from the renewable energy sources. So it is produced from the hydrocarbon. So that is the one of the threat, because when we come to produce the renewable energy, water electrolysis or biomass or some thermochemical cycle, the efficiency is still low. It's the theoretical efficiency, it's around 50%. So the real efficiency is always less than 30 to 40%. So that is the one of the major drawback to produce the hydrogen. Cost economically viable, but still people are finding new technologies and new membranes, new materials for the production of the hydrogen. So hope it will achieve soon.
So the next question is, what is the best method for water splitting to produce hydrogen?
This is one of the very challenging, very interesting question, because there are many methods are there. So I explained the electrolyzer, but the efficiency of the electrolyzer is very less, around 30 to 40%. But there are some other method. Thermochemical method means the hydrogen by using some chemicals, so chemical cycles. So like sulfur iodine, you may later Google it, sulfur iodine cycle. That was my PhD research. So that is also one of the method to produce hydrogen. So that is one of the good method. Compared to electrolysis, the efficiency is high, but that also has some challenges to need some hazardous chemical like sulfuric acid and hydroiodic acid. And as far as now, that is one of the good method to produce from the hydrogen from the iodine sulfur cycle, but it needs to be addressed by the handling of the heavy chemicals.
So the next question is that the weight and the volume of hydrogen storage systems are presently too high when we compare it with fossil fueled vehicles. Is there any suggestion to overcome it?
Yes, of course, because because when we store the hydrogen, it needs large tanks, very, very big tanks. So we cannot carry the big tank anywhere. And then we cannot run our car. Even we cannot keep the passenger in the car, but we have to carry the hydrogen. So that is the reason nowadays there are few methods, like I explained, the URFC, the unitized regenerative fuel cell. It's like a fuel cell. So when from the water, it can be stored as a hydrogen, and immediately it can be work as a fuel cell. So we no need to store the hydrogen. So the hydrogen, it's on site, it is produced, and immediately it can be used for the load. Like instead of storing, immediately loading. So there is no need of storing. So that is the only URFC we are currently working for that. And another one is, as I explained already, LOG, liquid organic carriers. So the hydrogen can be a big volume of hydrogen can be stored in the small volume of organic chemicals with some. So the hydrogen stored in some chemical bonds. So later, when we need the hydrogen, so we have to break the chemical bond, so the hydrogen can be released from the chemicals. So such way we can avoid the storage of the hydrogen.
So the next question comes from a participant named Denny Allen, and his question is that whether byproduct water in a hybrid vehicle should be filled in a periodic manner, or is there any other things which is available?
Actually, it is still the byproducts, as I explained, actually, still this is the proposed model, because to produce that hydrogen produced from the water, it's not enough. Okay, so the hydrogen. So when the reaction between the hydrogen and oxygen in the fuel cell as a byproduct is water, so that can be recirculated. So if we have some electrolysis unit in the car, so the byproduct of water will be recirculated to the electrolyzer unit, so that also can produce hydrogen, and that hydrogen also we can utilize for our fuel to run the car. Yes.
So the next question is, what are the factors that should be considered to insulate stored hydrogen?
So actually, it has some specific. Actually, It has some specific guidelines to store the hydrogen. So whether it is in the industry or whether it is in the car, so there are some specific guidelines from the hydrogen storage committee. So we have to follow that.
Sir, and the last question is from the participant named Lokesh, and his question is that why can't we use water gas shift reaction method for production of hydrogen?
Yeah. Okay. When the water gas reaction, right? It's just water gas reaction is just the water is converted into gas. So directly means heat energy. Then it can be used as the hydrogen, right? So the efficiency is less than 20%, because when we have a water, we have to make the water gas, and we have to heat the water is more than 2500 Kelvin temperature. So we have to give excess amount of energy in the form of heat. Anyway, it is heat, is whether it is electricity or whether it is magnetic energy or whether it is form of potential and heat. Heat is also energy. So we have to produce the hydrogen to give a excessive heat to get the low amount of hydrogen. For it is like we have to give to produce hydrogen 2000 Indian rupees and get hydrogen only for 200 rupees. So that is the reason most of the people do not adopt this water gas reaction for the production of hydrogen energy.
Okay, so thank you, sir, for answering all the questions which has been addressed by the participants.
Thank you so much.
Okay, thank you for your valuable time, sir. I want to conclude this session with a vote of thanks. I would like to express our sincere thanks to our guest, Dr. Emmanuel Vincent, for sharing his valuable idea about hydrogen energy and fuel cell in this webinar. I would also like to thank our beloved HODs for their moral support and guidance. I'm very happy to express our vote of thanks to our staff members for their valuable suggestion and participants who have made this webinar a great success. Thank you. Thank you all.
Thank you so much.
Thank you, sir. Hello, sir.
Yes, can I stop, sir?
Yeah, sir. Yeah.